this video, I'll show you what an asymptote is. I'll also show you how to find them. An asymptote is a line on a graph where a function approaches as it goes to infinity. The distance between the graph of the function and the asymptote approach zero as both tend to infinity, but they never merge. Here's an example of a vertical asymptote. The function approaches this line, although it looks like it touches, it never actually does. There are three types of asymptote. A horizontal asymptote is just a straight horizontal line on the graph. It can be expressed by y equals a, where a is some constant. As x goes to negative or positive infinity, the value of the function approaches a. A vertical asymptote is a vertical line on the graph. That can be expressed by x equals a. A is some constant. As x approaches this value, the function goes to infinity. For example, the asymptote might be x equals 2. An oblique or slant asymptote is, as its name suggests, a slanted line on the graph. More technically, it's defined as an asymptote that isn't parallel with either the horizontal or vertical axis. It can be expressed by the equation y equals bx plus a. As x approaches infinity, the graph of the function approaches this line. A function can have any number of vertical asymptotes, even an infinite number. However, it can only have two horizontal asymptotes at most. Functions don't cross their vertical asymptotes, but they may cross their horizontal asymptotes. In order to find a horizontal asymptote for a rational function, let's go over a few terms first. A rational function is a fraction of two polynomials like 1 over x, or x minus 6 over x squared minus 8x plus 12. The degree of the polynomial is the highest number raised to. For example, this is a second degree polynomial because it's raised to the second power. If we had x cubed, that would be a third degree, or x to the 99 would be a 99th degree. The coefficient is the number before the x. For example, the coefficient of 5x squared is 5, and the coefficient of 102x cubed is 102. So how you find the horizontal asymptote depends on what your function or equation looks like. Compare the highest degree polynomial in the numerator with the highest degree polynomial in the denominator. Choose one of the following. They're the same degree, the denominator has the highest degree, or the denominator has the lowest degree. I'm going to go over these one at a time. Let's start with number 1. Polynomials are the same degree. To find the horizontal asymptote, divide the coefficients of the terms of the highest degree. In this example, the highest degree terms, in other words the terms with the highest power, are 8x squared on top and 2x squared on bottom. If we divide those two coefficients, we get 8 divided by 2 equals 4. For this function, there is a horizontal asymptote at y equals 4. This graph confirms the location of the asymptote. Next, let's take a look at when the denominator has the highest degree. If the polynomial in the denominator has a higher degree than the numerator, the x-axis, that is y equals 0, is the horizontal asymptote. For example, this graph shows that the x-axis is a horizontal asymptote for 8x cubed divided by 2x to the 4th. Finally, let's take a look at what happens when the denominator has the lowest degree. If the polynomial in the denominator is a lower degree than the numerator, there is no horizontal asymptote. As I mentioned before, we can have two horizontal asymptotes. A horizontal asymptote happens when the graph of x is very close to a horizontal line. In other words, it flattens out and runs almost parallel to the x-axis as it heads towards infinity. As there are only two ways to head towards infinity on a graph, one in a positive direction and one in the negative direction, the maximum number of horizontal asymptotes any function can have is 2. Many different types of functions can have 2 horizontal asymptotes. Some rational functions can have 2 horizontal asymptotes. Their limits are always the same. So if there is a horizontal asymptote on one side, there must be one on the other. Absolute value and radical or root functions also have 2 horizontal asymptotes. Let's take a look at how to find a vertical asymptote. In any fraction, you aren't allowed to divide by 0. So if you have any error on the graph where your denominator is 0, you'll have a vertical asymptote. So to find out if a rational function has any vertical asymptotes, set the denominator equal to 0, then solve for x. Let's find the vertical asymptotes for this function. If you set the denominator, that's x squared minus 8x plus 12 equal to 0, you'll find the places on the graph where x cannot exist. Factoring that expression gives us x minus 2, x minus 6, which means the denominator will equal 0 when x is 2 or x is 6. Graphing the function, we can see that there are, as expected, vertical asymptotes at x equals 2 and x equals 6. If you can't solve for 0, there are no vertical asymptotes. For example, let's say your denominator is x squared plus 9. Setting that equal to 0 gives us x squared equals minus 9. That cannot be solved, so there isn't a vertical asymptote. Let's take a look at oblique asymptotes. You can find oblique asymptotes by long division. This isn't recommended, mostly because you'll open yourself up to arithmetic and algebraic errors by hand. Let's take a quick look at an example. For this function, we're going to perform long division, dividing the numerator by the denominator. We see the slant asymptote is at y equals minus 3x. I hope you found the video helpful. Please take a moment to subscribe to my channel, and I'll see you in the next video.